Hello everyone and welcome to KLE Society's College of Education, Ankola. My name is Anusha K and I am B.Ed first year teacher student studying in KLE Society's College of Education, Ankola. There is perhaps nothing so occupies the middle position of mathematics as trigonometry, as said by J.F. Herbert, 1890. You have already studied about triangles and in particular right triangles in your earlier classes. Let us take some examples from your surroundings where right triangles can be imagined to be found. For instance, suppose the students of a school are visiting Qutub Minar. Now, if a student is looking at the top of the Minar, a right triangle can be imagined to be made as shown in figure. Can the student find out the height of the Minar without actually measuring it? Suppose a girl is sitting on the balcony of her house located on the bank of a river. She is looking down at a flower pot placed on a stair of a temple situated nearby on the other bank of the river. A right triangle is imagined to be made in this situation as shown in figure. You know the height at which the person is sitting. Can you find the width of a river? In all the situations given above, the distance or height can be found by using some mathematical techniques which come under a branch of mathematics called trigonometry. The word trigonometry is derived from the Greek word tri, meaning three, gon, meaning sides, and metron, meaning measure. In fact, trigonometry is the study of relations between the sides and angles of a triangle. The earliest known work of trigonometry was recorded in Egypt and Babylon. Early astronomers used it to find out the distance of the stars and planets from the Earth. Even today, most of the technological advances methods used in engineering and physical sciences are based on trigonometrical concepts. In this chapter, we will study some ratios of the sides of the right triangle with respect to the acute angles called trigonometric ratios of the angle. Trigonometric ratios. The trigonometric functions we will be looking at sine, cosine, tangent, cosecant, secant and cotangent. Let us take a right triangle ABC as shown in figure. Here angle CAB is an acute angle. Note the position of the side BC with respect to angle A. It faces angle A. We call it the side opposite to angle A. AC is the hypotenuse of the right triangle and the side AB is a part of angle A. So we call it the side adjacent to angle A. The trigonometric ratios of the angle A in the right triangle ABC are defined as follows. Sine of angle A, opposite upon hypotenuse, cosine of angle A, adjacent upon hypotenuse, tangent of angle A, side opposite to angle A upon side adjacent to angle A, cosecant of angle A, hypotenuse upon side opposite to angle A, secant of angle A, hypotenuse upon side adjacent to angle A, cotangent of angle A equals side adjacent to angle A upon side opposite to angle A. Ratios of the angle do not vary with the length of the side of the triangle if the triangle remains the same. From geometry, you are already familiar with the construction of angles of 30 degree, 45 degree, 60 degree and 90 degree. In this section, we will find the values of the trigonometric ratios for all the angles and of course for 0 degree. Trigonometric ratios of 45 degree. Sin 45 equals 1 upon root 2, cos 45 degree equals 1 upon root 2, tangent 45 equals 1, cosec 45 equals root 2, secant 45 equals 1 upon cos 45 that is equal to root 2, cotangent 45 equals to 1. Let us now calculate the trigonometric ratios of 30 degree and 60 degree. Consider an equilateral triangle ABC. Since each angle is an equilateral triangle is 60 degree, therefore angle A equals to angle B equals to angle C is equal to 60 degree. Draw the perpendicular AD from A to the side BC. Now we observe that sin 30 degree equals 1 upon 2, cosecant 30 degree equals to 2, cos 30 degree equals to root 3 upon 2, secant 30 degree equals 2 upon root 3, tan 30 degree equals 1 upon root 3, and cot 30 degree equals to root 3. Similarly, for 60 degree, we have sin 60 degree equals to root 3 upon 2, cosecant 60 degree equals to 2 upon root 3, cos 60 degree equals to 1 upon 2, secant 60 degree equals to 2, tan 60 degree equals to root 3, and cot 60 degree equals to 1 upon root 3. Next, move on to trigonometric ratios of 0 degree and 90 degree. Let us see what happens to the trigonometric ratios of angle A if it is made smaller and smaller in the right triangle ABC. We have sin 0 degree equals to 0, cos 0 degree equals to 1, tan 0 degree equals to 0, cosecant 0 degree equals to 1, not defined, secant 0 degree equals to 1, and cot 0 degree equals to 1 upon 0, that is not defined. Now, let us see what happens to the trigonometric ratios of angle A when it is made larger and larger in triangle ABC till it becomes 90 degree. We have sin 90 degree equals to 1 and cos 90 degree equals to 0 and tan 90 degree equals to infinity. From the above table, you can observe that as angle A increases from 0 degree to 90 degree, sin A increases from 0 to 1 and cos A decreases from 1 to 0. Next, we will see trigonometric ratios of complementary angles. Recall the two angles are said to be complementary if their sum equals 90 degree. In triangle ABC, right angle at B, do you see any pair of complementary angles? In the right angle triangle ABC, angle C and angle A are complementary angles. That is, angle A plus angle C equals to 90 degree. We get sin 90 minus A equals to cos A, cos 90 minus A equals to sin A, tan 90 minus A equals to cot A, cosecant 90 minus A is equal to secant A, secant 90 minus A is equal to cosec A, and cot 90 minus A equals to tan A. Next, trigonometric identities. You may recall that an equation is called an identity when it is true for all values of the variable involved. Similarly, an equation involving trigonometric ratios of an angle is called a trigonometric identity if it is true for all values of the angles involved. In this section, we will prove one trigonometric identity and use it further to prove other useful trigonometric identities. Consider the triangle ABC. By solving, we get cos square A plus sin square A equals to 1, 1 plus tan square A equals to secant square A, and cot square A plus 1 equals to cosecant square A. These are the three trigonometric identities. Using these identities, we can express each trigonometric ratios in the form of other trigonometric ratios. This completes the lesson Introduction to Trigonometry. Please like, comment and share. Thank you.